Hi everyone, and welcome to the channel. So it's repair time again, and the project on the bench today is this Marconi TF2304 FM AM modulation meter. So this meter covers from 9 to 12.5 megahertz, and then again from 18 to 1000 megahertz or 1 gigahertz. So the RF input is a standard 50 ohm impedance. The maximum power that can be applied is 1 watt or plus 30 dBm, but the sensitivity extends down to at least minus 13 dBm, if not a bit lower than that. So the meter is very easy to use. Just apply the modulated carrier, select an extra 20 dB attenuation if needed, select AM or FM mode and the appropriate range, and then take the reading on the meter. And over here you can see it says battery, and there's a little black bar and the battery volts. That's for testing the internal battery, but this does not have the battery installed, so this is just AC line operated. The battery was for portable operation. And right here you can see that there's two outputs. There's an IF output, and this is an audio frequency output with a 600 ohm impedance. So that's the demodulated audio. That can be routed over to a piece of test equipment like an oscilloscope, or even an amplifier for monitoring the audio or the tone or whatever is being modulated on the carrier. So you could think of this meter as acting like a radio receiver that's continuously scanning from 9 megahertz to 1000 megahertz. And when it detects the carrier frequency, it just locks on to that carrier, and it stays locked until the carrier changes or is removed and then reapplied. So I've owned this meter for over 20 years. I used it several months ago, and it worked perfectly fine. Then I went to use it several days ago, and I noticed a problem. So let me get this connected over to my RF signal generator and also the oscilloscope so we can monitor the audio frequency output. And I'll show you what the problem is. We'll also take a look at the schematic. So let's get started and make this meter work again. All right, so let's take a look at what's not working correctly on the modulation meter. So you can see I have the RF output from the signal generator connected to the RF input on the modulation meter, and the demodulated audio signal is going over to the oscilloscope. So right now the signal generator is on 300 megahertz, that's the carrier frequency, and it doesn't matter what this frequency is set to, as long as it's within the range of the modulation meter, it doesn't affect the problem. I'll change this to a couple different values and you'll see the effect. So this is on FM modulation, so the 1 kilohertz deviation, 1 kilohertz tone for the modulation, and again that 1 kilohertz tone is being demodulated in this meter and going over to the oscilloscope, so that's the sine wave you see on the oscilloscope. And then 0 dBm is the output amplitude from the signal generator. So right here the high and low indicator lights are both turned off, and that's what you want to see because it means the output level is not too high or not too low. All right, so this is on 1.5 kilohertz full scale in the FM mode. So that's the second scale down. So 1.5 kilohertz full scale deviation. We're on 1 kilohertz and it's reading very, very close to the 1 kilohertz tick mark. So no problems. That range is working correctly. Now if I go over here to the frequency and I change this, let's go all the way down to, let's say, 10 megahertz. And there it goes. It locked back on and working correctly. You can see on the oscilloscope, no problems there. And let's go back up to, say, all the way frequency 1 gigahertz. There you go. The top end, the range, no problems. So I'll just put this back to 300 megahertz. It's perfectly fine. I'll just leave it on 300 megahertz for the rest of the test. So on this, leaving this on 1.5 kilohertz, if I change this deviation range switch to 2, so 1.5 times 2 is 3. So if I go to FM 3 kilohertz, it should go to full scale, and yes it does. Perfect. And that's working the way that it's supposed to. So we're reading on the 1.5 scale, but we're multiplying it by 2. And then if I go to times 10, of course 1.5 times 10 is 15. So if I go to FM 15 kilohertz, it should go to full scale, and yes it does. So perfect, no issues whatsoever on that range. So if I go to the next range, I'll put this back down. Let's go to, this is going to be 5 kilohertz, so I'll go frequency, so FM 5 kilohertz, put this back over to 1 kilohertz, and go to 5. So now we start to see a problem. So this is on 5 kilohertz full scale, 5 kilohertz deviation, but this is nowhere close. It's just hovering around in the middle, and it's not even steady. And it looks like the sine wave is pretty accurate on the output, but I do see some fluctuations as well. Seems a little bit unsteady there. It certainly is demodulating, but yeah, I mean, this is really all over the place. And just to show again that the frequency doesn't matter for the carrier, if I go back up to, say, 1 gigahertz, really no change. I mean, it's doing the same thing. So just go back down here, frequency 300 megahertz. So yeah, I mean, it's really hunting around and not accurate at all. Now, if I go to times 2, of course, 5 times 2 is 10 kilohertz. So if I go to FM 10 kilohertz, should be full scale, and no. Now that tells us something right away. We already saw that this switch works correctly in this other range, but in the 5 kilohertz range, this switch isn't working the way that it's supposed to. But the problem wouldn't be with this switch because this circuit is already working correctly over here. And we'll look at the schematic in just a moment and kind of see how this all ties together. And then if I just go to times 10, so 5 times 10 is 50. And if I go over here, FM 50 kilohertz, and again, we should be full scale and not even close. But it is demodulating the, you can see the signal is on the oscilloscope. So now if I go to 15 kilohertz, put this back up to times 1, FM 15 kilohertz. And yes, that is full scale. Now on 15 kilohertz, we're reading 1 scale down, so the 1.5 becomes 15. If I back that down a little bit, let's say I go to 10 kilohertz, you can see it's on the 1.0, but that's read as 10 now. So no problems there, that's fine. So that range is working the way that it's supposed to. And if I take this and I go to times 2, so now 15 times 2 is of course 30. So half of that, if I go to 15, for example, we go 15 kilohertz, should be about halfway, and yes, very close to halfway. 30 kilohertz should be full scale. Yes, it is. I wasn't looking at the oscilloscope there. It's too large of a signal. So yeah, no problems with that. And if I go to times 10, so that's going to be 150 kilohertz full scale. So again, 150 kilohertz, that'll go to full scale, very close to that. So I'm not seeing any problems with these other ranges, just that center range. Now let's take a look at the AM. So if I go over here, let's put this on AM, down to 10%, back up there. Deviation doesn't affect the AM settings because this is in the percent modulation. And I need to change this over here, FM. Let's turn that off. Let's go to AM on, and let's set this to, that was 10% full, so we'll go to, let's say, 5%. That should be halfway, and no problems. So that's reading correctly for AM. Let's go to this center range right there. So this should be 30. So half of that would be 15. So I'll just go to 15%. Well, not even close. So again, this center switch, for both FM and AM is not working correctly. So definitely an issue going on with that range. And then if I go here to the 100%, half of that, of course, is 50, so I'll just go 50%. And yes, very close to that. If I go to, let's say, 90%, of course, in the AM, we're reading down here in the red scale, and yes, very, very close to that as well. 80 there, 100, so 90. It's very, very close. So I'm not seeing any problems with any of the other ranges or any of the other functions other than this center range. So let's take a look at the schematic and see if that kind of points us to where the problem might be, given that it seems to be isolated to this one range. Also, as I'm pushing this button here, let me just go back down, let's say 30%. I don't think it's a intermittent connection on this switch because I've tried to push this. It really doesn't seem like that switch, if I jump around on those ranges, it doesn't really change that. I don't think it's switch contact problems. I've pushed the switches in and out a number of times, and I don't get the feeling that it's a switch contact issue. It does look like somewhat of an intermittent connection though, because look at how that's kind of jumping around. It's not steady at all, where it is steady in the other ranges. But let's take a look at the schematic and see if that kind of points us to where the problem might be. Here's the portion of the schematic that shows the range switches. So you can see the 3 switches right here. And the center switch, the 5 kilohertz or 30%, is the range that was giving us a problem. So the overall path that the signal takes is that the signal is arriving right here, goes through some amplification, big voltage divider with these fixed resistors and 2 potentiometers. The potentiometers are for calibration. There's a capacitor, and then it goes to ground. Now remember, this is an AC signal, so the AC signal will pass through this capacitor, but the capacitor will block any DC voltage that's in the circuit. Now of these 3 switches, only one can be selected at a time because of a mechanical interlock. So when the switch is selected, it moves over and it joins together here, or right here. So whichever switch is selected, it's picking off a different amplitude based on the value coming off of this voltage divider. The signal appears over here. Some more amplification. So the signal can make its way out over here to the audio frequency output. It's your demodulated signal. Signal can come down over here, make its way around, and ultimately to the meter. There's also some switching for the battery voltage test if there's a battery installed. Now, it makes sense that when the meter was not stable in this middle range, that this output was also fluctuating a bit because the signal's all originating at the same point. But taking a closer look back over here, we know that both the 30% and the 5 kilohertz ranges don't work correctly. It's all related to this single switch. And assuming that the switch contacts are okay, and I think they are, it really doesn't seem like intermittent contacts. If we go back a little bit further, the only other thing that I can see would be a problem would be the wiper on this potentiometer, which is R12, 22K pot. Because if the signal comes down here, if this fixed resistor, if this resistor was faulty, it would be affecting all of the ranges, because even this first range where it's just going directly off, it still is affected by all of this resistance going down to ground, okay? But if this wiper, let's say it's completely open, that would of course make this range not usable at all. But even if that wiper opened up, it wouldn't affect this range or this range. The signal would still go through this potentiometer. It just wouldn't be picked off on the wiper. So if this wiper has become intermittent or poor connection, then it would affect this range but have no effect on the others. If this resistor was completely open, or let's say the connection on the resistor was a cracked solder or something like that, that would certainly be affecting this range. I think it would be very noticeable in this range. I think it should have some effect on this range as well. Because again, the signal comes all the way down through this voltage divider to ground. So I think we need to take a look at R12, probably just clean up that potentiometer as a starting point and see if that takes care of the problem. If not, then of course cleaning these switch contacts. I really don't see a lot else in this circuit that would be related to only this range. So it looks like these components are, it says right here, they're on the main function board, so we'll have to locate those inside the instrument. So I'll take the cover off the instrument, start taking a look around. Let's get to these parts. All right, so after removing several screws, the cover slides off. This RF assembly pivots out of the way, and it gives access to that bottom circuit board. And I located R72, and that's the potentiometer for that middle range. Now earlier in the video when we were looking at the schematic, I misspoke. I called R72 R12. If we take a look here in the schematic again, right here, you can see this is R72, and I thought the 7 was a 1. But anyways, R72 is what's marked on the board. Now you can see this is a 22K potentiometer, and then this one is a 4.7K potentiometer, and there's several other fixed resistors around here as well. But actually, after looking at the circuit board, these values are different in the instrument that I have. So I think this is an older version of the schematic. There were probably some revisions done to the instrument. So let me show you what I found going back over here. So that potentiometer is right in this corner here, but it's actually easier to test it by just going to this back side of the board. So again, I'm just going to probe onto the board right in this area here. So on the digital multimeter, you can see over there it says OL for overload. When I touch the leads together, of course, that goes down to a low value. And if I go right here, this is the other potentiometer that checks good. If I go across it like that, see it's a 1K potentiometer. That's not what's actually marked on the schematic, but 1K potentiometer, that's obviously a good value. It hasn't just drifted or something like that. But if I go from the wiper to one side, basically about a half a K. If I go from the other side up to the wiper, very nearly that half K as well. So it makes sense. You're getting a reading off of the wiper from one side to the other, and those two values should essentially add up to the total value that you get across the potentiometer like that. So it makes sense, no problems there. Now here's the potentiometer on the range that's giving the problems. So I'll go across its complete resistance right there. You can see it's actually a 5K potentiometer, about 5.1, but basically just the tolerance, it would be a 5K pot. Now if I go down to the wiper, so wiper to one side, look at that, slipped off there. It's jumping all over the place. It's not even a stable reading, and look at how high it is, 62K. Well, you can't have more resistance than the total resistance of the potentiometer, so obviously the wiper has lost its contact. And then if I go over here from the wiper to the other side of the pot, again about 50 to 58, just shy of 60K. But it's all over the place, very unstable, and that fits with the readings that we were getting that were reading too low and not stable. But again, from the wiper to one side of the potentiometer and then to the other, that resistance shouldn't be higher than the total that we see there, which is the complete resistance across the potentiometer. So what I'm going to do is clean that potentiometer, work it back and forth, work some cleaner into it, and then we'll retest and see if it's improved. All right, I cleaned the potentiometer. I've worked it through its range a number of times, and I've reset it to the midpoint, so it should have about the same resistance from the wiper to each end of the potentiometer. Now, of course, this is a linear potentiometer, so that holds true. If it's a logarithmic type of potentiometer, then of course it's a logarithmic change as you go through the entire range, but again, this is a linear pot. All right, so let's retest and see if it's working correctly. So again, going from the extreme ends of the potentiometer, we have 5.1, 5.13. So I'll go from one side to the wiper. Hey, look at that. Much better. So 2.787. Very stable reading. No problems there. And I'll go from the wiper to the other end. Yeah, look at that. 2.494, 495. Excellent. And those two values add up to basically the total resistance, 5.1. Perfect. I think that's taken care of. Now I need to recalibrate the instrument on that range, and I might touch up the other range as well, just to dial things in exactly, because that potentiometer, you know, it's midpoint, but that's not really where it's supposed to be for the actual calibration. So let me reconnect this over to the RF signal generator, and let's make the calibration on that range, make it nice and accurate. All right, let's set the calibration on the middle range, and I'll double check the calibration on the high range as well. And there is no adjustment for the lowest range. Now I folded that RF assembly back down into position. I thought that would be a good idea because it might act like somewhat of a shield over this lower circuit board, and I didn't want to make the calibration and then fold that down and have it change the adjustments or the settings. So this way everything is put back together the best way possible, and there are holes in this lower circuit board to reach through and make the adjustments. So I think because those holes are there, they probably intended that to be closed up when you make these calibrations. All right, so let me turn this on right there and grab the RF cable. Plug this in right here. And right here we need to go, let's see, that should be on FM, like that. And then this should be the middle range right there. And then I'll turn on the signal generator. So like before, it's at 300 megahertz, 5 kilohertz for the deviation, 1 kilohertz tone, and 0 dBm output. So full scale indication here. What I'll do is I'll make the adjustment and I'll turn the meter down flat and take a look at the setting, because with this turn sideways like this, that could affect the accuracy of the meter. Also, if you're following along, you're definitely doing so at your own risk. You know, this is AC line powered, and there are exposed AC line voltages in the instrument with the cover removed. You need to be careful and not touch in the wrong locations. This is being powered off my isolation transformer for this testing as well. So again, if you're following along, take care, be safe. You are doing so at your own risk. So if I reach through this adjustment, go this way here, right there. So let's bring this back to full scale right about there. I'm going to look around the camera to the other side. Yeah, it's very stable now, not hunting around at all. That's right at full scale. Carefully tip this flat. And I'm looking straight on now at this front edge right here. Make sure that's touched up for you. And that looks really good. It actually didn't change to my eye looking straight on. It's right at the 5. That seems very, very good. Let me back off to, let's say, 2.5. Try that. So we'll go FM 2.5 kilohertz. Hey, look at that. Spot on. Excellent. Excellent. That looks really good. Very happy with that. Perfect. So go down to, that should be, let's try 50 here. 50 kilohertz. So we're on the 5, and it's just off a little bit. It's not quite at 50. It's reading a little bit under. Let's try 5 times 2 would be the 10. So let's try 10 kilohertz. That's very accurate there. That's right at full scale. So I'm going to leave that alone. I think that's perfectly fine. I don't think that can be really improved on. That looks okay. And let's try, well, we're on this one, the AM, so the deviation switch doesn't matter there, but if we go to AM, just put that back up, and switch this back over, FM off, go to AM on, and we're on 30%. Yes, we are, and 30%. So it's reading just a little bit under 30. I'd like to see that a little bit further over, but if I make that adjustment on the AM, it's going to affect the FM as well. So I don't know if much more can be done about that. It's very, very close. Let's see what that would actually go. I just moved that up a little bit on the modulation. It's 2% off. So I went to 32% modulation on the signal generator, and now it's reading full scale. That's so close. I really don't think that's worth trying to worry about. I think that's close enough. If I go back to 30%, yeah, it's very, very close right there. So there are some other calibration points in the instrument. Perhaps something else could be slightly tweaked a little bit. I'd have to look into that. So for now, I think that's going to be perfectly fine. And of course, you know, when you're making a measurement like this, when you're full scale, you'd probably want to go to the next range to start that measurement. So for example, if I went to the 100%, so now if we go 100%, and yes, it's right. See, again, it's just a little bit under. It's very close to the tick mark for 30. So if I go 30, 132, it's the same thing. See, now I went 2% higher and it's right on. So there may be something else in the meter that's just off ever so slight, but you know, it's only 2%. It's very close. So if I wind this all the way up, let's go to 50%. See, 50%. It's reading just a little bit under consistently on the AM, so perhaps there's something else. But this is actually on the other range. We need to check the calibration on this range. So let's do that before we get too carried away here with looking at the accuracy. But anyway, it is very, very close. So let's go back over here. What do I want to do? Turn AM. Let's turn that off. FM back on. And what I'm going to do is bring this over here back to FM. And let's see, that's 15 kilohertz. So let's go full scale, 15 kilohertz. Yeah, it's reading, it's very close. It's just a little bit off the end of the scale. But on the AM, it was reading just a little bit under. So if I bring that down on that calibration, then it's going to make the AM be just a little bit further off as well. So almost a compromise between the two. It's very close. I mean, it's almost right at the full scale tick mark. So on this one here, let's go to 10. Let's try that. There's 10 kilohertz. That's right on. That's exactly right on. So I'm not going to touch that calibration pot. That looks okay. I don't see any reason to mess with that. Try 30. There's 30 kilohertz. fine. It's right at full scale. Try 150 kilohertz. Just a little under again. Not a lot, just ever so slight. Let's just line that up a little bit higher and see. Right there. I think that's reading about full scale, maybe just a touch more. It's right near the full scale tick mark. That's 155 kilohertz. There's 156 kilohertz. That's right on when I look straight onto the meter here. So it's just slightly off, 6 kilohertz. So again, very, very close. And there could easily be some other calibrations in here that might be affecting that. This whole instrument hasn't been calibrated in a long, long time. I really need to do that and go through and check some of the other adjustments. But the main issue, it looks like it's taken care of with this middle range. Again, very happy to see that that's stable and very reasonable on the accuracy. So again, going back here, let's see, 5 kilohertz. So let's go FM 5 kilohertz. And deviation all the way up. Yeah, so there we're back full scale again. Perfect. So it looks like it's working very well. Happy with the results. That was an easy fix on that potentiometer, just cleaning things up. It's interesting that it was just sitting and suddenly that potentiometer lost contact. But anyway, easy fix. And for completeness, here's a look at the oscilloscope and the demodulated output from that middle range. So it's sitting on 5 kilohertz full scale, and very stable output, where before it was hunting around, kind of wiggling, not very stable. So looks excellent. So in the ×1 multiplier, there's ×2, there's ×10. So perfect, no problems. So I went back and took a second look at the calibration on the middle range, so the 0 to 5 kilohertz, just to make sure it was as accurate as I could possibly make it without getting into other calibrations in the instrument, just this one adjustment, just making sure it was dialed in as closely as possible. And I tried to dial in the AM modulation readings a little bit closer, but when I did that, the FM modulation readings are just too far off. So I went back and recalibrated on the FM modulation right at mid-scale instead of the extreme range. And I'm happy with the result. I think it's really more of just a linearity issue at this point on this meter movement. So let me show you. Right now, it's sitting at 1 kilohertz, but it's just a little bit under. The signal generator is right on 1 kilohertz. But again, this is just a slightly under, very, very close, not really a problem. If I go down to the next range below, you can see it's sitting ever so close to 1 kilohertz, but maybe just a tiny bit over. So on one range, we're a little under, one range, we're just slightly over, but both are extremely close. If I go back to the 5 kilohertz range, so it's very close to the 1, but slightly under. If I go up to 2 kilohertz, now it's right on. I mean, that's extremely close, so no issues there. If I go to 3 kilohertz, perfect. If I go to 4 kilohertz, again, extremely close. Maybe just ever so slightly above the 4 tick mark. And if I go to 5 kilohertz, now it's just a little bit beyond the full scale, right at 5. So what's happening is we're reading a little bit high on the high side, a little bit low on the low side. It's a little bit of a linearity issue on the meter. But again, the readings are extremely close, so I'm not seeing really any major problems there. And perhaps it could be touched up with some other calibrations, but that's for another time. This looks very, very good at this point. Now on the AM, if I go over here, AM, leave this alone, so that's on 30% full scale. Turn the FM off, turn AM on. And right now that's sitting at 16% modulation. And you can see that's essentially right on the 15%, because this is 30, so half would be the 15 right there. It's on the bottom red scale. So, it's 1% off on the modulation number. I mean, that's extremely close at this point. So I don't think it can be dialed in any closer than that. So this wraps up the repair on the Marconi Instruments TF2304 FM AM modulation meter. So the repair ended up being rather simple and straightforward, just some cleaning on the potentiometer and some basic calibration maintenance. But nonetheless, I hope you enjoyed following along. So if you did enjoy this video, you can let me know by giving it a thumbs up. And don't forget to subscribe, because there'll be many more videos coming up in the near future. Lots of projects in the queue, lots of things happening on the workbench. You won't want to miss any of those. And tap that bell symbol to be notified when I do post a new video. All right, as always, thank you for taking time to watch. And until next time, take care. Goodbye for now.